What's up, YouTube? Just making a video here. I'm calling Regrets and Resolutions. This is based on my 4-foot by 8-foot CNC computer controlled router. This is one that I finished on Labor Day 2013, and now that I've run it for a couple of weeks pretty straight, I've got some observations, some things that worked well and things that didn't work well, that I want to discuss about this machine. A couple of things, you know, I've made a cut almost every single night after I get home from work, and cut things on Saturday as well. So I have a decent bit of experience with this machine, so I see its limitations. There's several things that I will change, several things that I would change as well if I were building this thing from scratch. And I'll just go over those. I even wrote out a list so I can remember everything. First is the lead screws. So I used, as I mentioned in my other videos, 1/2 inch by 13 pitch, and that's threads per inch, all thread. And you know, it's this entire machine represents basically the cheapest option that I could do and get decent rigid machine with some decent accuracy. However, I'm going to make some changes. So lead screws are $10 for 10 feet, so it's $1 a foot, and I've got dual lead screws on the Y, or on the X-axis, and I've got one on the Y and one on the Z, and it's all the same stock that I have welded coupling nut for the connection, and it works okay. The problem is two things. One, it's really slow. If I'm running, you know, if I'm running these motors to their max, the best I'm doing is like 40 inches per minute. If I change, and what I'm going to change this Y to this weekend, this Y axis, is to a roller chain. So I'm going to take this motor that's over here. Instead of being mounted there, it's going to be mounted on this backslide. Sorry, I'm walking around the machine so much here. It's going to be mounted on the backslide up near the top, and it's going to have a roller chain that runs the length of the gantry, and it's just going to move along. What that's going to do is give me a bunch of speed. I will sacrifice a lot of torque. This assembly here will, I can't hold it back with my bare hand. It's got lots of pressure. Just with the mechanical advantage, the leverage that you gain with a long screw like that. The roller chain will get me a lot of speed. It will get me more accuracy only because of this. With the lead screw, this kind of lead screw, it's actually really helpful. You got 13 threads per inch, so you can get a good resolution. The problem is, it's not straight, so you can't see it, but when it's spinning, maybe I'll just pop it on real quick and show you. When it's spinning, it wobbles, and what causes that to happen is if I've got the feed rate too high, it will bind up on the nut, especially when it's in the middle of the gantry, just like it is now. So I'll show you this right here. Hopefully you can see it, and hopefully I can make this thing work. Sorry. I don't know if you can discern any wobble, really. Maybe a little bit. You can see a little bit of wobble. But what it's causing the nut to do is to flex up and down ever so slightly. And that's just added stress on the machine. So that's one issue. Another issue is on the really long X-axis. I've got basically 8 feet of all thread going all through here. Well, you might imagine that catches a resonance at some point. And so if I'm going it's about 15 inches per minute, and this is going full bore, it catches a resonance and it starts flapping. So it's, you know, it's torqued on both edges, but it's got a decent amount of play, and once you hit a resonance, every wave builds on the next, on the previous wave, and it just starts flapping really bad, and it causes the whole gantry to shake, the whole table to shake, just because of the shaking motion of the wave that's going through that lead screw. So when I get the cache up, I will be doing the X-axis also with roller chain, which is what I've used here to couple my 2 lead screws, but instead I'm going to use that down the length of the whole table and that's what's going to move the assembly. So that's the first one, is the lead screws. Next is the height. This one's pretty easy to see. I mean, I've got 20 inches of travel in the Z. As you might imagine, that gives the router area a lot of leverage. So if you were to push on a router when it's fully extended, it's going to move more than when it's all the way up, because there's just more leverage. It's more, it's multiplied. It's a lever. And because of the height, it moves too much. Now, I wanted this height so that I could throw a bookshelf in there, or a table, or any, kid's toy or whatever, and engrave something or whatever I want to do on it. So I wanted this height. So I think what I'm going to do in the upgrade to this machine is make it to where I can adjust the height. So if you see the side here, there's a single rib going up on the side, and then there's, just a stock piece. You see my 1 V-groove bearing, 2 V-groove bearing, and the third is right there. I'm going to make multiple, maybe just 2 settings. One up high that sets the gantry low, and one down low that sets the gantry up high, so I can adjust it every so often when I do a tall job. And if I never do the tall job, I'll just cut the bottom, 18 inches off this thing, and then gain my rigidity that way. So adjustable height might be nice. Rigidity definitely is an issue. More than that, though, there's rigidity issues in my backslide. So I've got a little bit of side-to-side play, which is what I just discussed. Just because this thing's so tall, it's got a little bit of that. But because I decided to go with this 3 V-groove bearing arrangement, I'll move my Y over so you can see it. Because I decided to go with that, I have created a moment, or a torque, area of torque, that causes my machine to be less rigid. So I was trying to get by, again, I built this machine by hand. I was trying to get by using less bearings, though I bought them. I bought a pack of 16 for the whole machine. There's the others that I never used. I will be installing those last 4. Something that I didn't anticipate was the kind of torque angle that's created by using 3 instead of 4, and I'm going to try and demonstrate that here in a second. Incidentally, this is the new backslide that I'm going to be mounting the Y-axis stepper motor to, and this also holds the Z carriage, you might say. I'm pretty pleased with this. This one, of course, quite obviously, I milled out on this machine. That's a nice thing about a CNC machine. It's just the evolution of technology. Once you have something that can cut something better, you can upgrade it. So this will be making its new parts, and eventually be making its younger brother that will replace it. Hey guys, out of the street! Those are my twins playing in the street. They know better. Okay, so here's a demonstration. You see that I have 3 V-groove bearings here, here, and here. And when you rock on this thing, it's probably imperceptible to you, but it's moving more than it should, and more than you want to in a router. Well, what happens is, since I only have 3, and this one right here, there's a moment created that causes, if I can get a decent angle, it causes this whole thing to flex inward. So it's pinned really well from this side, not from this side, and when you push or pull, or whichever direction you do it, it causes the back far corner to move in the opposite direction, which is undesirable. So I'll be moving it from the 3 arrangement to 4, 2 on each side, like you see on most other machines. So I see why I did it, and now that I've got a machine, I can easily do it myself. I'll be doing that on all the axes, including the X. The X side rails is another issue. I thought I was clever when I did this. It's just a piece of flat aluminum stock, bar stock, that goes the whole length of the table. Problem with this is, when you run it into the side of the table splits, and even with pilot holes, and this is MDF table, by the way, even with pilot holes, the table still splits, because this stuff is layered, it wants to, and here's a good example of it on the end, so you can get an idea of what it's doing. Where you have the screw, the table splits, and then you get an inaccuracy on the side. Now, I did do a flattening operation on my table so that everything would be more level, and that did help, but I don't know, I'm not too impressed with how this worked out. Doing aluminum angle on the sides would have been better. And for the next machine, that's what I'll do. Only problem with that is that you start encroaching on the cutting width, which is what I was trying to avoid with the design I use, but that's probably just a sacrifice I'm going to have to make. Number 5 is the router. At this stage, I had the router. I wanted to use it, and it's good. It's worked fine for me. It's had plenty of power. I've never had issues with it stopping on anything. And this is just a Ryobi, I believe, just a cheap one, the cheapest one that Lowe's sells, or Home Depot, whoever carries Ryobi these days. It's super loud. I've got neighbors, and I keep my garage shut for the most part, so no one's complained, but still it's loud in my house. It's loud in my, when we're trying to do family activities and trying to just enjoy each other. There's things like whirring in the garage, and it's super loud. You can barely talk over it, just the slightest bit. And I even took a video with it on just for fun, but man, it's so hard to hear what I'm actually saying in there. I don't know. I plan to replace this with the water-cooled spindle, which runs extremely quietly. This one, since it's air-cooled, has to push all that air through, and it just runs really loud. The vacuum's loud as well. That'll be replaced with a dust collector at some point. A bag. Blower with a bag dust collector. This will be replaced with a variable frequency drive, 1.5 or 2.2 kilowatt water cooled spindle, and it'll just run nicer, probably less run out, which is play in the bit at the bottom. So anyhow, and this one's only single speed as well, so it's just cheap. It's only got one speed, which is fast, and it's probably 1800 or 18,000 RPM. Actually, this says 25,000, but that's probably under no load. And it even says it. That's without load, 25,000 RPM. So that's another item. The last thing is the limit switch and e-stop, which I own. I finally hooked one e-stop up. It's not even officially on, except, it's wired in electronically, but I haven't mounted it to anything. And I'll be putting a second one on the gantry. And the freaking limit switch. Oh, cool. Thank you, buddy. He brought me some grass. Thank you. Now go play. The last thing is the limit switch. I burned myself on this. I should have done it, but I was just so excited to get my machine up and running. And when I was doing my table resurfacing, my flattening operation, I was doing the very last cut, and I programmed it by hand. Everything else I run with a program, like a CNC written computer program. The last one I did a by hand operation, and guess what? I ran it into the side of my table. It cut into my aluminum side rail. And so now I've got a flat, kind of a dead spot where the gantry shifts if I actually operate through that range, which I try not to if I want a decent part to come out. So I'm going to have to replace that now. I'm going to have to fix it. If I use my freaking limit switches, which I already own, I wouldn't have that issue. I would have had it, it would have stopped on its own, faulted out, been angry. I already showed you these stuff. These are the small, tiny little limit switches. They're called micro switches. And you just hook them up. Maybe I'll pull it out here for you. So that's just a word to the wise. I think, from Hong Kong, if you could wait 2 weeks, it's $3 for a pack of 10. And this thing will save parts of your machine from getting cut into, because this was a wood router bit, cut right through it. And now I'm using carbide bits in there. It would even have less problems. So do yourself a favor, install your limit switches before you start operating. It's not really focusing very well for me, but that's a micro switch. Oh, we got some more grass. Thank you. Oh, and you fell. You okay, Bubba? Yeah, you're okay. So those are my regrets and my resolutions. I'm sure a few more things will come up out of the machine. But again, I've been cutting cool stuff with it. My accuracy's pretty poor, but the repeatability is good. For all the faults it has, it will, do several passes. Like this item was the first iteration of the back slide I made. Even though it doesn't cut because of the deflection of the Z, even though it doesn't cut exactly the profile that I programmed it to, it will cut it in 3 passes, the same profile. So repeatability is good, accuracy is not. Precision is it's decent. So anyhow, I made some fun with it. I plan to make a lot more. Hopefully this is helpful to anyone planning their own machine. You can try and shoot me questions. I don't always check the comments to these videos, but if you have any questions, let me know. Thanks.